us from all the corners of the globe. SQL Server as a cloud service is going to be our topic for today. Very quick bio, like Julie mentioned, I've been working with SQL for about 10 years. Used to work at HP in Costa Rica. Now I do consulting out of Ottawa, Ontario. I'm an MCM and an MVP. If you want to reach me on Twitter, feel free to send me something at Warchaff. If you want to send me an email as well, feel free to send me something at warner@sqlturbo.com. My personal blog is at sqlturbo.com. And if you want to check out the company that I work for, it's pythian.com. And that's it for my bio. Let's jump into the actual material here. So here we go. The agenda for today. So it's a very quick intro to what we mean by SQL as a cloud service, and then I'm going to go in through detail mostly on the two main providers, which is Microsoft Azure SQL Database, Amazon RDS for SQL Server, and I'm going to go into just a little bit of info about VMware's vCloud Air service, this is very recent stuff. It was announced maybe like 2 months ago, so it's just like a baby type of service right now, but it's worth it just so everybody, everybody that came to this talk can say they heard everything about the latest, even including to VMware's kind of like newborn SQL Server service. All right, so some fundamental concepts as we go through that apply to the scope of our talk for today. So first of all, we're going to limit ourselves to public cloud providers, and by that I mean somebody that has their services up provided through the internet. I can go in with a credit card and I can just pay for the services right there and then, right? It's nothing like, for example, some type of hosting company where they can rent me some space or they can create some VMs for me, but I have to set up a contract and all this type of stuff. We're going to limit ourselves to public cloud providers. That's where we're going with Microsoft, Amazon, and VMware as well. We're going to scope this into database as a service. That's why I call the session SQL Server as a cloud service, is because it's not going to be SQL Server running on your VM. So we're not going to talk about SQL Server running on an Azure VM. We're not going to talk about SQL Server running on an Amazon EC2 instance. That could be a topic for the future, but it's not the topic for the presentation today. We're going to focus exclusively on the services that want to provide a full database as a service solution, so you don't manage hardware, you don't manage OS, you don't manage virtualization layers, right? When you're in conversation with people, this is also known as platform as a service. Obviously, platform as a service is a more general term, whereas database as a service is a more specific term, right? Platform as a service covers many things that are not database related. For example, off the top of my head, we have Azure Search, for example, which is a search engine that you can plug into your applications and runs on Azure. So this is platform as a service, but obviously it's not database as a service. And finally, just to reiterate, that we're not going to talk about running SQL on a VM. That's infrastructure as a service, and that means you manage a lot of the stuff, and you're responsible for a lot of the stuff that is abstracted away from you when you're doing a database as a service deployment, right? So let's go into some detail here as well as to the scope of what DB as a service is, right? So when we're running DB as a service, our provider is going to take care of everything that happens from the engine down. And from the engine down, I mean, for example, either Microsoft or Amazon are going to take care of the actual operating system that SQL Server is going to be running on. They're going to be taking care of the actual virtualization layer, whatever that is. They're going to be taking care of the hardware that, the final bare metal that is actually running everything, right? On DB as a service, the user or the DBA is going to take care of everything from the engine up. So it's going to take care of obviously deploying their databases, making sure that the data is correct, making sure that it has good performance, any type of SQL query tuning that can be done, monitoring to make sure that there are no issues happening. So this is still a user / DBA responsibility, okay? Now all these DB as a service offerings usually have some common service aspects and items on which they compete on. So for example, they have high availability. Usually it's very easy to set up high availability with these type of services. We also have on-demand scalability, so it means that we can easily go in and see if we want to increase CPU, if we want to increase RAM, um, we can do both easily with these type of services. Backups are one of the most mechanic and painful things that sometimes we need to do um, on our on-premise SQL servers. So this is one of the things that is easily taken care of and automated by a cloud provider, right? So, for example, Amazon or Azure are going to take all the backups from you. You don't have to worry about it, and then they'll give you some restore capabilities as well, right? So it's something to keep in mind. And then there's other pluses or minuses that really depend on the provider. And I'm going to try to go into detail on this talk as much as possible and as up to date as I could. I was looking into the latest stuff last night just to make sure that I was giving you guys a really up-to-date view on the offerings right now. So hopefully, take all of this as of valid as of today, but the cloud world is changing so aggressively and so much that some of this stuff probably will change in a month or something like that. And I'll mention some of the things that are actually out in preview right now as well. Okay. So the first one we're going to focus on for today is going to be Microsoft Azure SQL Database, and Microsoft in this case is very well positioned to be the main offer of database as a service for SQL Server DBAs, because I mean they control SQL Server, they control the SQL DB service, so it makes sense that it probably could be the one that most naturally fits. However, we'll go and see some more details into why it might be a little bit harder for some people to migrate into Azure SQL DB, and some scenarios where it could be more transparent just to go into Amazon RDS, and the reasons for those as well. Okay. So let's talk about service cost first. So Microsoft doesn't have an explicit licensing cost when you go into Azure SQL DB. So unlike on-prem, where you have to obviously license your course or your server, it's basically baked into the service cost. We don't really know what the component of the cost is on licensing, nor do we care, right? Simply we get a database and that's it. We don't have to worry about licensing it, and you can't use licenses that you have for it anyway. So even if I just bought a SQL 2014 last year, I can't repurpose that license and suddenly say, hey, I want to use it for Azure SQL DB. That's not how it works. So the service doesn't have the concept of a license at all. And it's billed by the hour, so that also applies as well, right? So you pay for the service tier, and they'll charge you by the hour. So for example, a database in the basic level, a full month of a database in the basic level, in the end is about $5, right? So it's fairly cheap if you think about it by the hour. Imagine all the hours in a month and divide $5 by that, and you'll see the cost per hour is not super high. And the service cost is it contains everything. It contains storage, compute, backup. They're all put in together into the service costs. Okay. So security is a big issue because when we put stuff in the cloud, we are basically opening up our data centers to the world. So these are the main security features offered by Azure SQL DB. So there's a server level firewall. So when you create a database, it goes into a logical server. It's not necessarily a physical server, and you can put firewall rules there. Now, lately, they introduced these database level firewall rules. So the advantage there is that if you were to have some kind of high availability setup, where you have two servers, for example, and a database that replicates between the two of them, then if you fail over the database, that firewall rule will carry over with the database. So this is very interesting, right? If some of you are already familiar with the concept of a contained database, well, imagine these are basically like firewall rules that are living inside the database, contained inside the database, right? So up until very recently, SQL logins were the only supported method for creating users in Azure SQL DB. But now, maybe I don't know if it's like maybe like a month ago or so, Azure Active Directory is in preview now. So what that means is that you can create either a principal on Azure Active Directory, so somebody could log on to their Azure Active Directory and then from there use their account for access to Azure SQL DB, or even better as well, if you have your on-prem Active Directory and it's federated to Azure Active Directory, you could even just tie the whole thing together with the regular single sign-on that users are doing from their own machines, right? So this will kill the pretty much what happened is that when you were having a big or large deployments of Azure SQL DB, you were having to repeat a lot of principles all over the different servers, and you had to maintain the different passwords and whatnot. So this will basically kill that problem eventually when everybody's migrated to the Azure AD, and it's our preview. Because basically you'll be able to just create the same type of setup that you would do on-prem, right, where you have a group on Azure AD and then you grant access to the group and then you forget about having to manually manage all these specific users. So one weakness of the service of Azure SQL DB that is being worked on but has not been released yet is that the endpoints are open to the internet and there's no support for putting an Azure SQL DB only inside a specific virtual network. So even though you have the firewall, and that's all nice and good, it's still you can ping, you can reach that firewall just facing the outside world, even if you didn't want any application server from the outside world to go into your database. So to completely close the loop there on security, we will have eventually an option to just put an Azure SQL database inside a virtual network, but it does not exist at the moment. And this is one of the many differences we're going to see with RDS, whereas RDS right now does give you the capability to put one RDS instance just inside one virtual private cloud, which is what Amazon calls it, and limit connectivity to just that virtual private cloud, right? So an advantage, on the other hand, that Azure SQL DB has is that Azure SQL DB is taking advantage of the new Microsoft model, right? So if any of you have been listening to Microsoft's communications on many different events like Build or Ignite, they talk a lot about, it's Microsoft does cloud first releases now, right? So everything goes in the cloud first before they would put it in the box product. And Azure SQL DB is definitely one of the products that really benefits from this because, we haven't even, SQL 2016 is only on the CTP stages. We're thinking maybe we'll see a release maybe in the first half of next year, but it's not really set in stone right now. But at the same time, we can already test and try out all these new features on Azure SQL DB that are related to security. So dynamic data masking, row-level security, always encrypted. All these are box features for SQL 2016 that are already available on Azure SQL database, right? And think about going forward as well. This will not only apply to security. Eventually, we might see new features hitting Azure SQL database, maybe a year or a couple of years even before they would hit the on-the-box product for SQL Server, right? So this is a summary of the configurations that you can pick for your database in Azure SQL DB. So a basic is very much just for like dev or test kind of thing. It's a 2 GB max database with only 5 DTUs, and I'm going to go into a little bit of detail on what the DTUs are in the next slide. So if you've never heard of how Azure SQL DB manages performance, this is how. It's a measurement called a DTU. And I'm going to go into detail as well. Just for now, keep it in mind that it's a way to measure performance, and that's it. Standard tier is where you can actually start doing production deployments. So most of the clients that I've seen usually will start testing the waters with something in standard, and if necessary, obviously they will go up to premium. So standard, lets you up to a max of 250 gigabytes. So a lot bigger than what we can do on basic. You can definitely put production size on standard. The only thing there is that standard obviously is limited. It doesn't have as much raw power performance-wise as premium, so it's limited to 10 to 100 DTUs, and again, just keep it in mind that's like a dial to increase performance. And then premium has 6 levels that go up to 500 gigabyte max, so again, even bigger databases and even more performance power that you can dial up all the way to 1,000 DTUs. So imagine when you go from basic, that's 5, and then you go to P6, which is 1,000 DTUs, then we're talking about there's a ratio of 200 times more performance power, right, from basic to premium. And then the last tier that was introduced is a premium P11, and the reason I put in a separate line item is because this one really bumps up the size limit, and this one has a 1 terabyte max. So you can create one database that is all the way up to 1 terabyte and 1750 DTUs, right? So at this point, obviously, we're talking about serious business here. Definitely something you can put in production and get a lot of horsepower on it. Clearly you have to pay for it, but I mean that's just like everything. You don't get anything for free, right? Just a quick mention of the DTU, because it's something that is definitely important. If you're exploring on using this service, you need to understand it, and it's something that's very different from how we think on-premise, right? So DTU is a database transaction unit, and it's really a measure, a blended measure of CPU, memory, storage, and concurrency. So what Microsoft did is to run a benchmark. They did like this OLTP benchmark internally on their Azure labs, and on these all type of different configurations they had for Azure SQL DB, and then they recorded, you know, the throughput they got for them, and that's how they came up with the DTU, that's basic, all the way to the 1750, that's a P11, right? So you're meant to use it as a comparison point. So I put an example there. So let's say, you know, I have this application I'm currently testing because we're interested in migrating to Azure SQL DB. Well, if I run 100 queries on basic, and this took me 10 minutes on my test, then what is expected of the service is that if I run the same 100 queries on standard 3, which is 100 DTUs, it's going to take me 30 seconds, right? And the reason for that is that there's a factor of 20x between the DTUs of basic and the DTUs of standard, right? So there's 20 times more DTUs between basic and standard, so I should expect 20 times faster response time between basic and standard 3. And that's where, you know, it takes that ratio that if it takes 10 minutes on basic, you should expect to see 30 seconds on standard. Now, obviously, this is all an estimate created by Microsoft, so sometimes during the day, you might not get exactly a 20 times ratio. Sometimes I've had tests where I actually get higher than the 20 times ratio, but on average, it should average out more or less based on the DTU difference, right? And again, this is very different because on premises, we're always thinking about, oh, well, what's the speed of my cores? Or how many cores should I deploy? Or how much RAM should I put in it? Or even worse with storage, like how many options do we have with storage, right? We can do magnetic, we can do tiered storage, we can do SSDs, and then we have to think about the IOPS, we have to think about the bandwidth, and we have to think about the latency. All this is abstracted away from us into one measurement, into one, you know, volume dial, into, you know, give me more power or give me less power, which is the DTU, right? So in this way, I think Microsoft's approach is a lot more future centric, because this is really what eventually the cloud is really good for, right? I don't want to know exactly or worry about a specific hardware configs. I just want a dial that will give me more power, or I want to turn it down as well if it's not as busy, or if my, you know, Black Friday is over and I don't need a P11 anymore. Well, then you can dial it down maybe to like a P1 or something like that and bring your costs to 75% less than they were on Black Friday or something like that, right? So this, like I said, this is where I think the power really is of thinking of what the things that the cloud can really do, very different than how it can do them on-prem. So so what is the, besides the nice thing about having it in the cloud and not having to worry about running everything manually ourselves, so what are some of the other services that Azure SQL DB offers? Well, we can do a scale up by changing the service level. So this includes the DTU change. So, you know, if my database is getting busier, I'm getting more users, and I'm running on a standard 1, then I can just go in, push a button on the portal, and bump it up to standard 3 and get double the performance that I was getting before, right? So it's on-demand scale up, very easily done. And this is done online as well, by the way, by Azure. It's not immediate though, and sometimes it's hard to estimate, especially if you're moving between tiers. Like if you were moving down from premium to standard, sometimes that means there's data movement, so it might take longer than, for example, moving from standard to standard 3. But right now, unfortunately, when you move, you just have to wait, and it'll be done eventually. One good thing though is that you don't get billed uh, for the change in the tier until the conversion has completed. So if I move from, let's say, it's standard 0 to standard 3, I'm not going to get billed for standard 3 until the whole conversion has happened. So if it took 3 hours to convert, those 3 hours I was still getting billed on S0. And if I do it the other way around, well, I'm not going to get the decreased bill until the conversion happens, but at least during that conversion time, I'm still going to be enjoying the S3 level of service, right? This also means that, for example, you don't just have to focus on scale up, but you can also focus on scale out, right? So let's say you have a bunch of different customers and they're on separate databases, then you can manage that individually, and you could have one customer be on standard 3 and another customer be on standard 0 and manage that way. And there's even more tooling regarding the actual scale-out capabilities as well. I've actually done a full session just on the scale-out tools, but I'm just going to do a really quick intro for the session for us today. Backups with point-in-time restore are available thanks to Azure SQL DB. The retention is dependent on the service that you pick. So right now, I believe it's 1 week for basic, 2 weeks for standard, and up to 35 days for premium. If you need a backup that will last longer than that, then you have to export it yourself. And it doesn't do a binary backup export. It's basically that pack that will come with the data. There's 2 types of high availability that Azure SQL DB will offer for you, a standard and active. Think of this as, read replicas or just standby replicas in the case of an availability group. A standard one, you can't read it. An active one, you can read it. So a standard, you will pay 50% of the price because, you can't really query off of it. An active replica, you'll pay full price because it's assumed that because you made it active, it's because you want to query it, right? The system manages the version and deploys new features, so you don't have to do really much anything there. Like, for example, this always encrypted, I have a bunch of Azure SQL DBs running in the cloud that I use for test, dev, and whatnot. Simply one day I got an email that said, hey, always encrypted is now available on your Azure SQL DB. I didn't have to touch anything. I didn't have to do anything. There was no downtime actually published for that change either. So it simply, suddenly there's like, boom, a new feature available. Go ahead, take care of it. If you want to use it, go for it. Something that's also different from on-prem is that total database encryption is actually available on all the levels, same as auditing. So unlike on-prem where TDE is an enterprise feature and SQL Audit is also an enterprise feature, there is a service for auditing and TDE available for all the levels of Azure SQL DB, all right? Now there's the main difference as well from Azure SQL DB and RDS is that it not only has that individual database model that I've been describing, but they've been introducing this new model called the Elastic Database Pools. So this model groups multiple databases. So you can put multiple databases inside one pool of resources, and then they can share their DTUs inside the pool. So if I have a database that, let's say, is fairly quiet, but then gets noisier during the day, and then it goes back to being quiet. So instead of just having a static, let's say standard 100 DTUs forever, I can put it inside a pool where it shares those DTUs with other databases so that they can both move up and down in resources during the day. So the goal of the pools is to provide a better cost and performance ratio when you're dealing with many databases. Instead of having to deal and manage the performance individually of one database, then you do it on a group of databases, right? And to further go into what I mentioned before about the scale-out capabilities, this is a differentiator that Azure SQL Database has, especially from Amazon, and is the entire set of tools that Microsoft has built for scaling out database tiers, which is an attractive proposition, especially for, let's say, SaaS providers, where you sometimes have multiple databases or you have multiple clients inside one database, and then you space those out, maybe based on region or based on industry, or sometimes you go all the way and you have one customer per database kind of thing, and you end up with 1,000 databases, right? So these tools are deployed right now in the cloud by Microsoft, and they keep working on them and making them better. And they attack exactly this type of scenario where you want to have a scale-out database tier. So there's a .NET library that'll make it easier for you to code your application against a distributed database tier. There's the service model I just mentioned, the elastic pools for easier resource management. So you can put a bunch of different databases inside a pool and see them go up or down. There's what is called an elastic database query, which basically means you can set up a table, which is kind of like a view inside an Azure SQL DB, and from there you can query all different tables inside many other databases, and it looks transparent as far as your query goes. So that's pretty powerful stuff as well. There's elastic database jobs, so you can set up a script and point it to a group of databases, and then it'll just run that script against all the databases. And if one of them fails, you can pick up the reason why it failed and retry and all this stuff. And something that wasn't available until very recently is distributed database transactions. So this is now in preview, and it basically means you can do now a distributed transaction between Azure SQL databases. And like I said, this was not available before. There was no concept of a distributed transaction that was enabled on Azure SQL DB. Now there is. So with elastic database queries and with the new distributed DB transactions in preview, they've basically taken the linked server on the box functionality and ported its own version into Azure SQL DB. All right. And just show you guys here a diagram of what a full elastic architecture looks like. So for example, on the number one, you can see we have, let's say, a set of sharded databases. That would be, let's say if I'm a SaaS provider, it would be all my customer databases. On number two, I could have my client app built with the client library that they made for .NET to make it really easy to add or create or delete the new databases. On number three, we can see all the databases were put inside an elastic database pool. Number four, if I need to run any type of T-SQL script over all the databases, I can do that with an elastic database job. Number five, there's a tool called a split merge tool. So if I need to move data between different databases, I can do this with this cloud service called a split merge tool. And number six, if I need to, do a query over a group of databases but show it as just one database and make it seem as if I'm just querying one database, then I can use this new elastic database query capabilities, right? So this is, like I said, this is a big differentiator from RDS, for example, that does not provide such an extensive tooling for this type of particular scenario, right? Main limitations of Azure SQL DB. So you can, if you have to work with linked servers, then you can do a linked server into Azure SQL DB, but you can't really do a linked server out of Azure SQL DB. If you need to do any type of thing like that, then you're limited right now to the elastic queries, and elastic queries right now only work with Azure SQL DBs. So you can't do something like link from an Azure SQL database to an on-prem SQL server. If you're doing replication, Azure SQL DB is supported as a subscriber only for transactional replication only. If you have some .NET CLR modules, you can only use safe assemblies, so nothing that goes into unmanaged code that we consider unsafe. If you have, big investments on SSRS, SSIS, SAS, these are not part of the service. You will need to deploy your own VM and run those services off the VM, though you can run the database engine off of Azure SQL DB, right? So you could point either SSRS, SSIS, or SSAS just to Azure SQL DB, and don't point them to the on-prem SQL server, other than, for example, SSRS needs a report server to be on-prem or to be in the VM for SQL Server, but other than that, it could get the data off of Azure SQL DB. And in general, think about instance level tools. Most of those are not available because they work mostly on instance level or don't translate well to the cloud. So far they haven't implemented Service Broker for Azure SQL DB. I don't know if they will or not. Database mail is not implemented. If you wanted to do something like log shipping, you can't do that either. So those type of service limitations, you don't have as much control over those things because what you're provided, like I said, is more of a just is a database and it lives in the cloud, right? Real quick, I just want to show you guys the portal and what it looks like for Azure. So hopefully I'm going to switch over to a VM and you guys will be able to see it. Okay, so I'm just going to go and do a quick rundown of the portal in case anybody here is not familiar with it. Uh, you have a left panel here where you get all the different things, the options of what you can create. I'm going to go into SQL databases right now, and it's going to show me a list of all the databases I have, and it'll give me the location of those databases, the description, the pricing for each database and whatnot. And I can create a new database if I want as well. And I just want to show you guys all the different performance tiers. So let me go in here into pricing. Here we go. So you guys will be able to tell. Let me zoom in here just so you can get it real big. So we can see P1, P2, P4, they all go up to 500 GBs. They'll tell you exactly how many DTUs are being used for each one of these. And we can go all the way to P11 here, right, to do the max amount, the 1 terabyte one, and then we go into standard, right? And standard is 10 DTUs. And let me move down here so we can see all the standard offerings. So standard will go to 10 DTUs all the way to standard 3, which is 100 DTUs, and then from there it's just basically the one left is basic. Now, if you look at the prices there, mine are showing in Canadian dollars, so instead of being $5 for US, it's about $6 for 1 month of a basic. If we go up, the maximum amount for standard, the 100 DTUs one, is a 182 Canadian, so that's about 150 US. So it's very competitive pricing too, if you think about it. If it's an application just using one database and you can put it in the cloud and basically just pay 150 bucks a month, and you don't have to worry about uptime, you don't have to worry about the backups, and you can dial it up or down the performance. It could be an attractive proposition. And that goes all the way up to like the 1 terabyte P11, and obviously there, to justify that one, you definitely need to have, do some type of some research on your own, because you will be going all the way up to $8,000 a month, right? So it's a lot more money, and it might, depending on the usage, you might be able to justify either a full SQL Server on a VM or even an on-premise deployment instead of a P11, right? But if it's a database that already is an application that is developed in the cloud and the cost of having it on your own would also be pretty high, then it might make sense in the end to have it as an $8,000 a month database. It really depends on your use case, and you have to do the math to figure that out, all right? Okay, so let me go back into my slides. So let's go here. And now we're going to start talking about Amazon. So Amazon was really the first big cloud provider. So many companies that we talk to nowadays, they've made some investments into AWS, but interestingly, most of those are really as virtual machines, right? So if you're running SQL Server, RDS is pretty much just like a normal SQL Server, except they've put some automation on top of it, and then they've put some limits on it. So I find it is not as future-looking as Azure SQL DB, which is a lot more platform-centric, and we'll continue to see benefits from the Microsoft Cloud First type of deployment. But if you already have stuff on Amazon and you have some, what I think is really the sweet spot is some legacy systems that are really stable that you think can go on RDS, then it can be a great choice as well. So let me go now into RDS, and let's start looking into the details for it. So for example, we look at the service cost for RDS. First of all, a license is required, so it's not like Azure SQL DB. You have two options: either Amazon provides the license or you provide the license. So if Amazon provides the license, it's called, pay as you go. So Amazon is the one that is going to cover the license, and then if you use that license for 3 hours, then you get a higher hourly rate because you're basically borrowing Amazon's license. If you already have an agreement with Microsoft that allows you to do license mobility, then you can talk to your rep, verify that, and if you do, then you can move the on-premise licensing to RDS. Depending on what you're going into, usually there's Express, Web, Standard, and Enterprise offered by RDS, but these are linked specifically to SQL versions. So it's not like Azure SQL Database where you can think of it as kind of like a fork of SQL Server, right, where it just continues evolving on its own and it's its own thing, its own version. Now, Amazon RDS, you have to pick a specific SQL version that you're going to go into that you're targeting, right? And then the cost is a little bit different too because it's not a blended cost of everything, but instead you pick something related to compute, so how many cores, how much RAM, then you pick an option related to storage, so where you're going to put your data files, your log files, and then you might actually also have an extra cost with backups. And then the whole thing together, that's going to be the cost of your RDS instance, right? Let's talk about security for Amazon. So there is also a server level firewall. Only SQL logins are allowed as an authentication method for SQL Server on RDS. Now this is the bigger weakness that Amazon has that Azure SQL DB has now attacked with the Azure AD implementation. So like I said, it's in preview now, but in the very near future, you're going to be able to just extend your AD into Azure SQL DB and forget about just using SQL logins. Well, RDS doesn't have that, and it's not in preview, and I don't know if there's any roadmap to have it in. Right now, the solution is you can only use SQL logins, right? The advantage that Amazon does have is that if you want to really have a full tight control over who can access your RDS instance, it is allowed to be put specifically into a one virtual network. It doesn't have to be facing the internet at all, even the outward firewall. Okay. And the other thing you have to think about, though, that's a big difference from Azure SQL DB, is like I said, all the new features of SQL Server, they will hit Azure SQL DB first, such as dynamic data masking, row-level security, always encrypted. All that stuff is now in Suite Preview on Azure SQL DB, but Amazon is forced to follow the bigger on-box releases, right? So whatever security features you have are what is available on the version of RDS SQL Server that you picked, right? So it could be either 2008 R2, 2012, 2014 standard. You're limited to that, right? So let's talk about the configuration choices when you create an RDS instance. So the license is separate from the config choices. So first you pick how you're going to license it. Then the instance choices are the same as a VM. So this is very, you know, Amazon's deployment model is very, very similar to just deploying a new machine. The actual models of the machines are mimicking the virtual machines. So it's nothing like the DTUs where, you know, it's abstracted from you. Here is basically the same thing. You have to pick cores, you have to pick RAM, and you have to pick storage very specifically. So this is very similar to doing an on-prem deployment or a virtual machine deployment. Very different from Azure SQL DB, which is really truly platform as a service and abstracts those decisions away from you. Some common configs that are deployed on RDS, for example, M4, the M machines are the general configuration machines that Amazon provides. These usually have a good balance of cores, RAM. R3 is one that works really well with SQL Server because these are called memory optimized, and basically what it means is that usually they have double the amount of RAM that a general config machine will have. So if, let's say, a general config machine has 4 cores and 8 gigs of RAM, then R3 will have 4 cores and 16 gigs of RAM. And obviously here everybody's a SQL DBA. We all know how hungry SQL Server is for RAM, right? So R3, in my opinion, if you're going to deploy a nice high-performance RDS machine, you should deploy an R3. And then I'm going to mention this a small one called the T2, should hold burst instances. And this is really only for very small databases, but it's kind of cool what they do. What they do is that CPU runs at about 20% on average, and if necessary, it can burst to 100%, but it only lasts for a certain amount of time, and then it goes back down to 20%. So this is attractive price-wise. If you have a small databases that are not that busy, every now and then they get some queries and they need to burst up. It's definitely not for anything considered high performance, high concurrency, or anything like that. It's just for very small deployments, right? like I said, on RDS, you do have to make your own storage choices. So RDS offers three types of different storage. What they call the general storage SSD gives you a baseline of 3 IOPS per gigabyte, and this can burst up to 3,000 IOPS. By burst, I mean it's a similar concept to the CPU bursting. If you push it hard enough, Amazon will let you burst to 3,000 IOPS for a certain amount of time, and then after that it goes back down to 3, and you start accumulating credits for when you can burst again. So if your workload looks like a wave that goes up and down, then general storage could work well for you. The more high performance storage is called the provisioned IOPS storage, which is also SSD backed. It's 300 IOPS per gigabyte, and it can burst up to whatever amount you reserved. And the max is 20,000 IOPS, right? So this is for high performance servers that are 24/7. There is no wave of up or down. It's always, somewhat busy. Then you want provisioned IOPS storage. And then last is just magnetic. And normal magnetic hard drives don't have any performance SLA related to them, so they're not really recommended for anything production at this point. Just if you want to do something like deploy a dev copy or a demo copy for somebody to play around with, and you want to do it on the cheap, then you can do it on magnetic. Okay, so let's talk about what Amazon does as part of the services in the platform besides just, managing hardware and OS. So you can do instance scale up as well, just how you can do it on Azure SQL DB. However, on Amazon, when you change the instance model, you will have to reboot your SQL Server. And this is something that's very important for everybody here to understand. The only thing that you can scale up on RDS once you have deployed is CPU and memory. You cannot scale up storage. The choice you made when you created your SQL Server in RDS, you are married to that choice unless you create a brand new RDS instance with the new storage that you want, and then migrate everything from the old RDS to the new RDS. There is no transparent scale-up of storage for RDS SQL Server. RDS does this for MySQL, it does it for Oracle, it does it for Amazon Aurora, but it does not do it for SQL Server. SQL Server is the only technology in RDS that does not allow you to do storage scale-up as of today. Okay, so it's incredibly critical for somebody that's considering putting production stuff on RDS to understand this limitation. That's why I mentioned before in the webcast, and I have a slide there to go into, what are the migration scenarios that I recommend, is that RDS is a sweet spot really for very stable applications or legacy applications where you're not suddenly going to have some kind of unexpected growth or storage is going to get out of control from you, because this is a big limitation where you can't just easily, press a button and get more storage at it, right? Amazon provides backups just as Azure SQL DB does, and Amazon is kind of nice. You can actually have configurable retentions. So on Azure SQL DB, if I have standard, I have a 2-week retention, but if, let's say, I wanted a higher retention, I just want to pay some more, I can't. I have to go all the way up to premium to get toward the 35 days. Amazon, on the other hand, I can create whatever type of machine I want, and I can set my backup retention completely independent of that. So if I want to retain 10 days of backups, well, they'll charge me for 10 days of backups. If I want to retain up to the 35 days max, then they'll just bill me more for that. But it's completely independent. So that is something that I do like from RDS. I would hope that eventually Azure SQL DB will provide a freedom like this, but for now it doesn't work like that. Amazon can do the patching. Usually you initiate it through the portal if you want to patch to a new version of SQL Server that they have deployed, either usually a service pack or a full version upgrade. These are not online or anything like that, though. You'll have to take a reboot for sure. What you want to do as well, because you never know what's going to happen, is you'll take a snapshot before the patch or the version upgrade just in case, right? But other than that, you don't have access to the operating system or anything, so you have to let the service do the patching on its own. If you want to have high availability, it is available right now and is provided through database mirroring. So Amazon calls their RDS HA multi-availability zone deployments. Under the covers, it's implemented as database mirroring for SQL Server. And if you want to use TDE, you can, but you have to be licensed for it, so it means it's limited to enterprise licenses, right? Now, some of the limitations, the main service limitations of RDS, well, storage can be changed. I already spoke in length about that. 30 database max per instance. I didn't put it here, but actually the max size of a storage for one instance in RDS is 4 terabytes. So if you have something bigger than 4 terabytes, it's not going to fit in one RDS instance. Right now, it goes all the way up to 2014 standard. So if you need a version like 2014 Enterprise, is not available on RDS right now. There are no distributed transactions to another SQL server. You can create a link server into RDS, but not out of RDS. Replication is not officially supported, but I've gotten it to work to be a subscriber. I just have to do a few tweaks on it. Publishing definitely doesn't work at all. .NET CLR, same as Azure SQL DB, only safe assemblies. Amazon doesn't want you to crash their server with some crazy unsafe assembly. Same as Azure SQL DB, what you're getting is the engine. So SSRS, SSAS are not part of the service, and you would have to deploy them on a VM as well. Very similar to Azure SQL DB as well, instance level configs are not available, such as service broker, maintenance plans, database mail, etc. Right? So let me do a demo now, just show you guys real quick RDS, what the portal looks like in case you're not familiar with it, before we go into the quick the VMware slides. So this is the main AWS console. If you're not familiar with it, you can pick your region on the top corner. RDS is right here on this on the left side. I have the mouse on it. I'm just going to click on it now. And then that brings you to basically your RDS dashboard for whatever region you're on. You can go into instances and you can see what instances you have running. Right now, I'm going to zoom in here to show you guys. I have a SQL Server Standard Edition instance running. It's just called DBA demo. Status available. You can see the type of machine I picked here. So the class is it's an M4 large machine. So like I said, M4 is the general config ones. It says it has a virtual private cloud that I deployed it in. I can go into look at a lot more details here when I expand on the portal. Amazon will give me some baseline of performance monitoring. So you guys can see it right here. I can see CPU, memory, how much storage I'm using, how much of my storage is pushing, read, write, IOPS. And I can see all the details as well in one dashboard here for my actual database. So I can see I'm running here standard edition. It's license included, so I'm basically borrowing the license from Amazon. I can see the endpoint that I can use to connect to it, if it's publicly accessible, what port I'm using. Let's see what other information is there. Oh, and we can see here some of the other details here, for example, if it's available right now, if I'm doing a multi-availability zone, if there's backups, latest restore time that I would have available, if it's encryption enabled through TDE or not, all that is available there on the dashboard. And if I wanted to connect to it, well, then what you do is you pick up the endpoint here from Amazon, make sure that your machine is firewalled, and then from that endpoint you can connect with Management Studio. Just to show you real quick, for example, right now I have my Management Studio and I connected before both. I have one Management Studio, you guys can see it's transparent. I have on Object Explorer both my Azure SQL DB server called Elastic Test and my AWS RDS SQL Server instance called DBA Demo. So in that regards, it's pretty transparent as a DBA to how you connect to both. You can just use Management Studio, and there's nothing special about it. All right. So let's finish up with VMware. So this is a very new stuff. VMware's vCloud Air for SQL Server. Service cost is right now it does not include a license as like a pay-as-you-go thing where you borrow the license from VMware. So you have to be either buying a new license that you're going to put in the cloud or use license mobility, and you're going to pay very similar to Amazon. So you pay compute, storage, and backup separately as a blended bill for this vCloud Air offering. Some of the info that we have right now on it is it was just announced September 2nd, 2015, so it's a couple of months old at this point. There were two initial offerings. I didn't get a chance to check, but this is what they had maybe like a month ago. So two offerings for a SQL Server that you want to put on this VMware cloud. It's just a 2-core 8 gig, 4-core 16 gig, so it's not for monster systems at all. It's pretty small. 150 gigabytes per instance at the moment, so again, it's not for a giant database, pretty small type of database. And they were offering 2008 R2 or 2012 at the moment. So they didn't have a 2014 offering when I checked last. So for now, not really exciting. It's just like very brand new service. But I think we can all agree that VMware is probably deployed in every single one of the companies that we work for. So if there's a big company that can do a big play in the cloud, it's VMware, and now its parent company, which is Dell, right? So Dell purchased EMC, which had already purchased VMware. So it could be interesting. Keep an eye out for this. Maybe in a year or so, we'll be talking more seriously about deploying things on the VMware cloud as well, on top of Azure and Amazon RDS. All right, so quick summary of all the stuff we saw today, and really what I think is some of the migration criteria that you can follow if you're trying to think about, should I go to RDS or should I go to Azure SQL DB? Well, if you have one instance that has a lot of cross-database dependencies and a lot of code that uses 3-part names to access different tables on different DBs, then Amazon RDS will probably be better for you because you can put all those databases inside one instance and the 3-part queries will still work. So that's just one plus for RDS. If your database is stable or legacy and is not going to grow unpredictably, so RDS could also be good because, you know, what we don't want is to be on RDS and then have to change our storage. We're going to have to take downtime if we do that. So yeah, you don't want to be having to switch storage out when you create RDS instances. Obviously, if you need anything that is in 2014 Enterprise, like in-memory OLTP or clustered column store indexes, that's not going to be available yet on RDS. The max it goes right now is to 2014 standard. 2012 Enterprise is on RDS though. So 2012 does go to Enterprise, 2014 right now only goes up to standard. And if you just prefer a setup that mimics really closely what the box product is, then RDS will definitely be way more than that than Azure SQL Database, right? So Azure SQL Database, on the other hand, if you have a new application that you're building and it's being hosted or built right there in the cloud, then you know this is a good service to think about because it is really platform as a service and is really future thinking. You get all the features right away, and you really deal with platform as a service in that, you know, Microsoft will dial up the DTUs when you request it. They have the elastic scale-out capabilities that they're adding, so you can create database pools and increase the size or decrease the size of these pools. If you want to have access to the latest features, well, Microsoft now deploys cloud first, so again, that will go into Azure SQL DB. And you have to be okay, though, with a more platform-oriented approach, right? It's not going to be as similar as how similar RDS is to SQL Server, right? So you have to be able to just, you know, give up control of some things and learn how they work in the cloud now, all right? So at this point, Julie, let me know if we have any questions. I think we still have a couple of minutes, and we can go over that.
Yes, you do have a couple questions. One was, isn't that transparent data encryption and not total data encryption?
Yeah, transparent database encryption, TDE.
Okay.
So if I have it on the slide, maybe I made a typo or something, I call it total, then yeah,
Okay.
it's the same thing. So yeah.
Is the split merge tool like Azure Data Sync, and is Azure Data Sync going to be released soon?
Yeah, so Azure Data Sync is deprecated, and the split merge tool is not kind of like Azure Data Sync. Azure Data Sync was more like a replication tool between Azure SQL DBs and on-prem to Azure SQL DB. Right now, if you want to do a replication between Azure SQL DBs, you're really limited to maybe Azure Data Factory, and which is really the replacement for Azure for the data sync service. And if you want to do replication from on-prem, you can now do it with normal SQL replication, so that covers that gap. The split merge tool is not really an equivalent to any of those tools because the split merge tool is specifically for scale-out scenarios where, let's say, I have customers inside a database and then I want to move. It's not a replication tool. It's a data movement completely a complete data movement tool. So I want to move one customer out of one database and into another, or I want to split the ranges of my database tier into more databases or merge them into less databases, then I can do the split merge tool. So the split merge tool is very closely tied to the Elastic database tooling. It is not a replication tool, and it's not meant to replace replication tools. And Azure Data Sync is not getting released anytime soon. Like I said, it's been pretty much deprecated. If you had anything invested on Azure Data Sync, then look into Azure Data Factory or just a full-blown SQL replication from on-prem to Azure SQL database.
If mirroring is being deprecated, why is
Anything else?
yes. If mirroring is being deprecated, why is it included in AWS as HA?
Well, that's what they decided to use, right? It's in the end, it's platform as a service, so I don't really care what they're using as long as they can sign off on the SLA that they owe me. Then that's what they decided to use. And also keep in mind, deprecated doesn't mean it's not going to work or suddenly it has bugs or something like that. I still deploy database mirroring on my clients, even though it's deprecated, if the use case is there for it. For example, if I have a client that's going to do a cross-domain deployment and they have SQL Standard, they don't have a SQL Enterprise to deploy an availability group, then still database mirroring is the best solution, and I can create endpoints that are verified with certificates. Just because it's deprecated doesn't mean it's not supported. Now, why Amazon chose it, I think it's because it's probably it was the easiest thing for them to use and deploy for everything, because they have to maintain all the different versions. So it'll be a lot harder for them to just have a HA version, meaning availability groups, that only works with SQL 2012 Enterprise, and at the same time have to support database mirroring for the SQL standards, whereas mirroring will cover everything, right? So again, I'm not an Amazon engineer, but I guess that's probably why they chose it.
I wasn't sure if you covered it. They were specifically asking about the price differences between Azure and RDS.
Price difference, it really depends on what you're trying to deploy, because the models are not the same at all, right? So like I said, RDS mimics an on-prem deployment very closely, where you pick the specs of one instance and then that's what you deploy. It's very similar to deploying a virtual machine. So it's a blended price of storage, compute, backups, whereas Azure SQL DB, it just gives you one price for the entire package of the database, or one price for the entire package of the database pool. So it makes no sense for me to throw a price comparison, because I don't want to mislead anybody. The way to do this, the best way to do this, is if you have something on-prem or on a virtual machine that you think is a good fit for both of them, both Amazon and Azure have online price calculators. So go and play around with the online price calculators and see what they give you in terms of how many databases you're going to move, if you're going to use the individual model or the pool model in Azure SQL DB, or how many cores and RAM you need on RDS. It's very different, especially because Azure SQL DB as well, it doesn't give you cores and RAM counts or storage IOP counts or anything like that, right? It only gives you DTUs. So a one-to-one apples to oranges price comparison, it's really hard to do without having a specific use case and having measured that use case as well to see exactly what tier you're going to use, or in Amazon's case, how many cores and RAM you're going to need and how much IOPS you're going to need, and so on, right?
Right. Just a few more questions if you still have time.
Yeah, I have a couple of minutes.
Okay. How would you get around the limitation of database mail not being available in Azure SQL DB?
Yeah, so this is something that is not available, and it just requires you to think differently. For example, if let's use the Azure scenario. You could create something like a job on Azure scheduler that will check if your Azure Elastic job failed, and then send the database, send an email through an Azure service, right? So Azure has a notification service, so you could use that to send emails. Same with Amazon. I'm pretty sure Amazon also has a notification service, and they also have this thing called event subscriptions that will allow you to set up some alerts and send emails based on that. So the answer is you have to use a separate service. The good part is that any cloud provider has a notification service that you can plug into, but it does mean that you're going to have to, script something on your own. So that if you have a lot of stuff that you've implemented on database mail, then maybe these type of services are not for you, and you should just go with virtual machine instead.
What is the availability that a provider guarantees, and do providers have maintenance windows that need to be accommodated?
So it depends on the provider. I believe Microsoft right now is offering 4 nines for their databases. I'm not sure what the RDS one is. You have to look into the license terms for RDS. Um, Both for RDS and for Azure SQL DB, if they're doing any underlying maintenance, it should be transparent to you, or at least that's what the SLA says. Now, obviously, it's in the cloud, so it doesn't mean that um, they're not going to violate their SLA. I know that if, for example, they cause some downtime unexpectedly for some reason, then they'll just basically credit you the cost of the downtime on your credits. That's just something that comes with the territory of running in the cloud. To mitigate this, obviously, if you have a production environment, then you should use their high availability options, right? So if we're talking about Azure SQL DB, use the replica option, either the standard or the active one. And if you're using AWS, use their multi-availability zone deployment, i.e. database mirroring option, so that in case Amazon suddenly their rack falls over and it's a big region outage, you have your other copy running another Amazon region. Same with Azure, right? If you, for some reason Microsoft suddenly has a fire and it affects the database, the rack where it was running somewhere in the Azure data center, then at least you have the other copy, right? So if you're thinking about deploying production, definitely you're going to have to factor in using their high availability options, because in the cloud we can't control these things. It's not like on-prem, and your applications also have to be able to detect if, oh, I disconnected, let me try connecting to the primary again, and after a certain amount maybe I should just go and try their secondary. So it's just the world of the cloud, right? You have to plan for these types of things that might happen and they're out of your control. And as to specific SLAs, yeah, it's in the documentation somewhere, but they both definitely agree to some SLA, but if they violate it, they'll just credit you for the time. They're not going to credit you because, suddenly your company lost $1 million in sales. They're just going to credit you the couple of hours that your database was down in the cost of the database, and that's it.
Also, how would you get around the linked server limitation?
Sorry, what was that?
How do you get around the linked server limitation? I guess you can't have linked servers when you're in Azure.
How do you get around the what server?
Linked?
Oh,
Uh,
the link server limitation. Yeah. So um, if you need to do linked servers, if you need to link from, let's say, a full SQL server to an Azure SQL database, that works fine. But if you need to link can you hear me?
yes, I can now.
Okay, so if you need to link into Azure, that works fine with an on-prem SQL. Just create a normal link server. But if you need to link out, it doesn't. There is no concept of a link server officially. If you're interested in that, though, there is a new functionality. They just call it an elastic database query that basically allows you to go out of the Azure SQL DB, but only into another Azure SQL DB. If you really needed to go out of Azure SQL DB into an on-prem SQL, then you're going to have to use some kind of data movement service. Could be Azure Data Factory or something like that, that will move the data for you from the on-prem SQL into a cloud database that you can link from. So yeah.
Does Azure SQL Database offer extended events?
Yes, actually, it was just released maybe like 2 months ago. I don't know if it's general availability now, but it's definitely on public preview. So if you're interested, just Google it up. Just Google Azure SQL DB extended events. I did see that it came out already, and it works pretty much like on premises. You can send your extended event files over to Azure storage, or you can just send them to a ring buffer inside the Azure SQL database and query your events from there. So yeah, extended events is available now. I'm not sure if it's general availability or public preview, but either way, it is there now. You should be able to test it out.
For those using Azure or AWS, what's the response time from the service provider? As far as what's the normal response time for resolving issues? There have been rumors of long times to resolve issues in some cases. Is this true?
Yeah, well, I've had clients that have had good experiences with support from Microsoft, bad experiences with support from Microsoft. Same with Amazon. The only thing I can say is that if you are serious, and this is my, the actual advice, if you are serious about putting production stuff in the cloud, just pay for the support contract. I think the minimum amount that Microsoft charges for a support contract is like $300 a month. Amazon might be something similar, and that allows you to open a certain amount of tickets without them charging you any more. But if you're going to put stuff in production, you at least definitely want that. Now, other than that, to say, well, they might, even with that, they might take a long time to resolve the actual issue they have. Well, there's not much you can do about it, right? And both of them, like I said, you have to take advantage of their high availability options. So even if they do have an issue, that is mitigated even on their side, right? So multi-regions for your databases, both on Azure and for AWS, if you're gonna put them in production.
That's great. The last question was wondering about having access to the slides. So if you're willing, if you could send me your slide deck, I'll be glad to post that to our website
Oh
as
yeah,
well.
no problem. So I'll email Julie the slides, and you can post it on the chapter website. Yeah, no problem.
Okay. Well, thank you very much for attending the presentation this afternoon. It was quite informative. We really appreciate the time that you spent putting this together as well as with the demos. It was really great. We will be
Great. Well,
posting the recording to our website either today or tomorrow. Thanks again.
thanks everybody, and have a good afternoon, and hope to see you in another session in the future. Thanks, Julie. Talk to you later.
Thank you. Bye, Warren.
Bye.